Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of modeling slope-intercept form. This is standard 8.5i in the great state of Texas, and we are using item number 4 off the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we got a gas company charging $16 a monthly service fee, and then you've got the 0.6924 or 6,924 10,000ths per 100 cubic feet of natural gas used during a month. So which equation best represents y? The gas company's monthly charges in dollars for using X 100 cubic feet of natural gas. Now this is seemingly a simple problem, but there's a little bit of a trick here. So let's first get our slope-intercept form out here, right? So when we're talking about slope-intercept form, this is a common form of linear equations that we're going to see. Y equals mx plus b. All right, so we know what our y and our x are, right? So our x is going to be our independent variable. So we start with that, plug it into this equation, do something with it, multiply it by x, add the b, and then you get your y, your dependent variable, because the value of y depends on whatever you do to x. So when we're talking about slope-intercept, really we're talking about these other two letters. So b right here is my y-intercept. So if you were to graph this, right, you would graph it and you would look to see where does this line cross the y-axis, right there. So if x equals 0, then you can figure out what y is, because if you put a 0 right there on x, then anything with that m is not going to really matter, and that's just going to be 0, because anything times 0 is 0. So that tells you what that is, that y-intercept, and then finally we've got our b, and this is our slope. Now if we're trying to calculate this, right, we're going to take the change in y over the change in x, or the rise over run. We can take two different y coordinates, two different x coordinates, subtract them over each other and get it. But sometimes they just go ahead and give us the slope, or in this case it's going to be that rate that we're going to calculate. So we've got 16 bucks, and we've got this decimal here, and we got to figure out which one is the slope, which one is the y-intercept, and are we adding or subtracting? Okay, and the reason why this is tricky is because it says that $16 is a monthly service fee. So when we see that, we think, oh, it's a monthly service fee. That sounds like a unit rate, which sounds like m, slope. But let's get into this second sentence here to kind of help us, because it's actually going to give us a little bit of a clue. So I'm going to increase my transparency a little bit more. So which equation best represents y? The gas company's monthly charges. So y is the monthly charges, okay? So it's not like this is a yearly equation. This is a monthly charge. So y is the monthly charge, and then x is 100 cubic feet of natural gas. There we go. So that x is really going to give us our clue. So y equals, and that y is going to be the monthly charge. X is 100 cubic feet. Well, which of these amounts deals with 100 cubic feet? Well, look at this. It's this right here. Per 100 cubic feet. Per. Multiply. So we're going to have to multiply this 0.6924 times x. And then we add or subtract the monthly service fee. We add that monthly service fee. So normally we would see monthly and want to make that the unit rate, but since y already is just the monthly charges, then that is actually a y-intercept. It's just going to be 16 bucks plus this unit rate times the 100 cubic feet of natural gas that is used. And so you see our answer here is going to be D.